Now starting. All attendees are in listen-only mode.
Hi, good afternoon and good morning to everyone. Want to introduce myself. I am Elizabeth Cassatelli. I'm the Channel Development Manager here at Henkel, and we are excited today to partner with HISCO to bring you this webinar on medical technologies, capabilities, and applications. Before we get started, just want to go over a little housekeeping. Everyone is on mute, so if you do have any questions, please use the portal to type your questions in, and we will do our best to answer all of your questions at the end of this webinar. Today, our presenter is Christine Murata. Christine holds a BS in chemistry and an MS in technical management. She has been with Loctite since 1992, holding various roles within our organization, including application engineer, business manager for Henkel's medical and filtration segments, and most recently as the North America Business and Market Development Manager for the Henkel's medical business. Christine has been published in numerous technical articles and white papers related to adhesives for medical device assembly and has served as technical speaker at various events. Today, we've partnered with HISCO to bring you this exciting webinar. HISCO has been a valued partner of Henkel Loctite for a number of years, providing a value-added services and products to lower the total cost of manufacturing across the entire supply chain for an organization. HISCO offers their customers a variety of solutions, including vendor-managed inventory programs and documented cost savings programs, which has given customers $110 million in savings to date. So with that, I'm going to now pass it over to Christine, who will now be presenting our webinar on medical technologies, capabilities, and applications.
Thanks to Elizabeth and to HISCO for inviting us to talk to you today a little bit about our medical technologies. So on your screen, you should now see the agenda for the planned topics for the next 40 minutes or so. We'll start with a few general topics and capabilities as they relate to medical device adhesives. We'll then spend quite a bit of time actually reviewing the actual adhesive technologies themselves, some benefits, considerations. We'll then roll right into a review of common applications and then wrap up with some of the support and resources that are available to all of you as clients of HISCO and Henkel. And then again, any wrap-up questions and we'll do through the portal, as Liz said. Okay, so let's get started. So first, I just want to make sure we're all sort of oriented to the same point or idea, and that is just defining exactly what is an adhesive for medical devices. So an adhesive for medical devices is really something that's specifically designed for the assembly of medical devices. It's designed to fulfill a specific requirement for a medical device application. So this would encompass everything from the assembly process, biocompatibility, and then any specific documentation that would be required by you guys as medical device manufacturers. What I will say is you'll notice that there's no reference to any kind of in-the-body usage. Medical device adhesives are very specifically different than a medical adhesive, which might be used for wound closure or for surgical applications. So just want to make sure we're clear on what that distinction is. With regards to biocompatibility, that's one of the key uniquenesses of medical device adhesives. And when we talk about biocompatibility, a lot of folks are familiar with the term USP Class 6. So USP stands for United States Pharmacopoeia. And really, this was one of the earliest standards that was developed at the time to determine the suitability of polymers, in this case, plastic materials, for use in actual medical devices. There were several classes under the USP governance. However, the Class 6 really specifically referred to materials that came in contact with blood or bodily fluids. Shortly after the plastics or the substrate folks started testing to USP Class 6, folks like Henkel Loctite also began to test our adhesives to Class 6 as well. Things have shifted a little bit. Back in the late 80s and early 90s, there was a lot of discussion about USP Class 6 and really moving to a standard that would be more global. And this is where the ISO 10993 standard really became discussed and more popular and was really implemented around the mid-90s. It was first actually introduced in Europe, and now it really has become sort of the global standard for biocompatibility. On the right side of your screen there, you see several of the key benefits of why folks like Henkel, as an adhesive supplier, shifted to ISO from the Class 6. Those include things like it really is a more comprehensive examination of biocompatibility effects. There's more statistical significance because there's more replicates in terms of the testing itself. The testing under ISO 10993 actually is, we believe, more relevant because you're actually using extraction temperatures that are more consistent with body conditions. And it also incorporates additional tests above and beyond what was included in the original USP Class 6. So here on the left side of your screen, you see the original 3 tests that were the primary focus of USP Class 6. They included systemic toxicity, a muscle implantation test, and an intracutaneous toxicity test. And so again, those were the basic 3 tests that were included under the USP Class 6. When you contrast that now on the right side of your screen with the ISO test, you can see there's about another 9+ tests. And these are only some of the 9 key ones that are listed here. But you also notice one of the key things is that the tests that were part of USP Class 6 are also encompassed in ISO 10993. However, again, you have another 6+ tests that are at your disposal under the ISO 10993 standard. So from a Henkel perspective, in our case, each adhesive supplier or material supplier can really define what testing they're doing since we're not an actual device manufacturer. So in the case of Henkel's ISO 10993 testing protocol, we've determined that there are 5 key tests that we will utilize for all of our medical device adhesives going forward. So again, once again, you'll see the 3 tests from USP Class 6 are listed there, the systemic, the muscle implantation, and the intracutaneous. And then we've also added in the cytotoxicity and the hemolysis testing as well. One note to make here is that Henkel does not do any of this testing ourselves. We have always involved an outside third-party laboratory that specializes in this kind of testing. This is not something that we do on our own. So again, what benefit does the biocompatibility program from a company like Henkel or Loctite provide to you? Well, first and foremost, by doing this testing, you folks as adhesive designers or manufacturers or specifiers, you'll have some comfort knowing that the adhesive has already been tested to a common test protocol. One note to mention here is that the adhesive is always tested in the fully cured state. Adhesive in an uncured state or even a partially cured state will actually not pass biocompatibility. So it's really critical that the adhesive itself be fully cured. The second note there is the fact that, again, the idea behind this testing is that as you guys take the adhesive and embed it into a device that you're then going to submit to the FDA, that the risk for that final device to fail biocompatibility as a result of the adhesive is reduced. So again, that's pre-screening, just gives you a little bit of added comfort knowing that going forward, the adhesive, if properly used and cured, should not cause any biocompatibility issues. And the hope is that by doing this, that your device submissions to the FDA for a PMA or a 510K and any sort of audits that you get involved with would hopefully be shortened. And I put a note online on the screen here that you can actually download all of our biocompatibility certs at the website that's referenced there. And you'll see just an example of one of the certs shown on the screen to the right. And again, in this case, we were working with the Toxicon was our previous biocompatibility partner. And today we're working with NAMSA, but both 2 widely known biocompatibility testing laboratories. Again, a final note just with regards to biocompatibility. In no way does our testing, the Henkel biocompatibility testing, replace what you folks as medical device designers and manufacturers need to do. Again, this is meant to be a service and help minimize testing and risk, but not meant to replace any of the testing you might do with the full device. So we'll go on to another medical specific topic or capability, and that has to do with sterilization. We get a lot of questions because inevitably every medical device goes through either a single or multiple cycles of sterilization. So I want to start with a couple of very common ones, gamma and EO or ethylene oxide. So in the table on your screen, you see a couple of different things. Starting on the left side, you see the products or the adhesive chemistries listed there. So starting at the top, we have a gel cyanoacrylate. And we'll talk a little bit more about these chemistries as we go forward. Then you have a series of light cure acrylics, rigid and flexible versions, and then a category of adhesives called light cure cyanoacrylates. The second column shows you the substrates that were used. So in this case, PC stands for polycarbonate. In that first line under the cyanoacrylate gel, you'll see we bonded polycarbonate to polycarbonate. In the case of gamma, we actually did 2 doses of sterilization. We did 2.5 megarads and then 5 to 10 megarads. And then on the EO, you'll see on the right, we did either 1 cycle or 2 cycles of EO. And what this chart is showing you in terms of the values themselves, this is actually the percent of the initial bond strength that was retained following that sterilization exposure. So you can see that in general and overall, looking at the numbers, most of the numbers are well above the 100 range or in that 100 range, which means 100% of the initial strength is retained, and you'll see in some cases the strength's actually going up to the 130, 150, 200 range. And the theory behind that is that many of these chemistries are actually radiation curing, and gamma certainly is a form of radiation. So in some cases, the belief is that there may be some additional post-curing that's occurring as part of that gamma exposure. The only anomalies that we really see in this particular table when we talk about sterilization impact is in the second row where you have a light cure acrylic. And in this case, it's a rigid version of a light curing adhesive, and it was bonding PC or polycarbonate to glass. And if you look to the far right for the EO data, you'll notice that in this case, we actually dropped our retention of strength down to about 70 or 85%. And the theory here is that this is really more of an effect of differences in the materials that were bonded. You have a PC and a glass, which have very different coefficients of thermal expansion. And the thought is that that played a significant part in why you see a little bit of strength loss there. But as a general rule, gamma and EO with most adhesive chemistries actually perform very well and not really a concern area. We'll go on to one additional sterilization discussion. That's with regards to autoclaving, especially with folks that are doing non-disposable devices or devices that, for whatever reason, your customers want to be able to reuse more than once. Many times we will get asked how adhesives perform with regards to autoclaving. And the first statement just highlights the fact that most adhesives, and this includes cyanoacrylates, light curing adhesives, silicones, polyurethanes, etc., they all do fine typically with 1 to 2 cycles of autoclaving, and this is whether it's 121 degrees C or 132 degrees C. Again, typically we see minimal effect. It's when you start getting to additional and repeated cycles, 5+, that really we begin to see some degradation of some of the more traditional chemistries like the cyanoacrylates. In this case, if you have a device or an application where you expect it to be exposed to a rigorous environment like an autoclave for more than, let's say, 3 cycles, it typically is recommended that thermoset medical device adhesives, things like epoxies and some of the other things we'll talk about in a few minutes, be your material of choice. And I'll just alert you to something we'll talk about towards the end of the webinar, and that is there are some new medical device adhesives that we have introduced and more will be coming. And these may be potential candidates for some of the more aggressive sterilization methods like the autoclaving we talked about, or some of you may be familiar with some plasma phase hydrogen peroxides, which have also been a little bit challenging for adhesives. Okay, so we'll shift over now and talk specifically about some of these adhesive technologies that were previously mentioned in the sterilization table. And before we get to that, I just want to highlight a couple of thoughts about why our clients and the folks we work with tell us why they choose adhesives. And really, typically the very first and foremost reason is the fact that with adhesives, you can really combine a lot of different materials. This is not the case with a lot of welding techniques. So whether it's glass to metal, plastic to metal, plastic to plastic, or plastic to rubber, adhesives truly are one of the assembly means that does allow for quite a versatile basket of assembly possibilities. It also, using adhesives, does give you some new possibilities in design. You can actually bond and seal in one. We've had a lot of clients, especially of late, who are doing a lot of miniaturization of parts. And again, having the adhesive as a means of assembly facilitates some of the small part assembly that they need to manage. From an aesthetic perspective, and you really clearly see this in the image on the right side of the screen, most of our adhesives are invisible from the perspective of they're clear colorless, whether in the uncured or cured state. So in the case of lots of different medical devices, most designers do not want a big glob of adhesive or a fastener or something highly visible. So from an aesthetic perspective, adhesives do achieve that goal as well. And then the adhesive method can also be combined with other methods as well. So if you have a mechanical fixturing, but let's say you need some sealing, it can be combined with other mechanical fixing methods as well. So there's actually 7 key technologies that Henkel offers from medical device assembly. We're going to actually cover 4 of the key ones here today. The first, light cure acrylics. We'll then go on to cyanoacrylates, light cure silicones, and then we'll wrap up with epoxies and hybrids. So here on this table, you just see a couple of the main features for each of these, more as a reference guide. We're actually going to go into some of the key benefits and challenges with each of these. But here you kind of see a snapshot overview of sort of their main feature or why they would be selected. So the first one we'll start with is the light cure acrylics. Most people refer to light cure acrylics just as the light cure category. This is probably the most commonly and widely used type of light curing adhesive, especially in the medical device market. The primary reason clients, designers, manufacturers choose light cure acrylics is the fact that they do offer rapid cure. It's referenced here as less than 30 seconds, but you'll see when we get into some of the device-specific application areas, we have many clients that are curing these adhesives in less than a second. So certainly speed of cure is one of the key things. They're easily automated, and because of that rapid cure where nothing additional is going to be happening after they are exposed to light, you can immediately QC your parts. So we have many clients that cure, and then within less than a minute, they're actually doing a pull test, a leak test, or some other kind of destructive test to ensure viability. On the consideration side, probably the biggest issue here, and these are really older issues, and when we talk about some of the LED advancements shortly, you'll see that safety and capital expense were some of the classic considerations when it came to light cure acrylics. These have really been mitigated now with the advancements in LED technology. And then really probably the main consideration here is just substrate transmission. In the case of light cure acrylics, one of the key factors is that you have to get light to the bond line. So when you look at the different kinds of light cure adhesives that are viable, you'll see in that first upper left-hand box that there are UV-only versions, there are UV-visible versions, and there are pure visible versions of the acrylic. So really, you can pick and choose depending on what kind of light source you have, what kind of parts you have in terms of transmission, but a wide variety of curing capabilities available. The majority of adhesives, I would say probably in the last 10 to 15 years, have been introduced, have fluorescence in them. So although that clear aesthetic that we talked about earlier is really critical, it was also a challenge for many designers and manufacturers to ensure that the adhesive was actually on the part. There are now blue and red fluorescent versions of many of the light cure acrylics. And then on the far right side, again, a high viscosity version. Again, a wide range of viscosities are available, but in recent years, some very high viscosity non-slumping versions were also introduced. On the bottom, then you see some of the newer things that have come out in the last, I'd say, 2 to 3 years. One that's coming out actually imminently from Henkel Loctite and it'll be offered through Hisco are some highly flexible light cure acrylic adhesives. These demonstrate elongation on the order of 100%. So this is a tremendous advancement in terms of the elongation perspective. They are also designed to be fully curable with LED systems. This has also been a challenge that we've heard from many of our clients in the past. And they offer high adhesion to some of the flexible substrates that have presented real challenges in device designs and manufacturing. And I'll share some data in a moment on that. But I also want to just mention also the fact that, again, the LED curing systems have really been a significant enhancement when it comes to light curing acrylic adhesives. And actually, Hisco's hosting another webinar, I think, coming up in October, so watch for news of that, which will be specifically covering LED curing and LED curing systems that Henkel's offered. But you can see there on the screen some of the key benefits that LED curing systems offer. So again, speaking about the new highly flexible adhesives that will be forthcoming in about 2 months officially from Henkel, what we're presenting here is some of the adhesion data for these new adhesives. So again, these are light cure acrylic chemistry. This data is showing you shear strength data in newtons per millimeter squared, and it demonstrates on the screen there how they were actually cured. They were cured using a 405 nanometer LED. The first table shows you the shear strengths on polycarbonate to polycarbonate. So no surprise here, the flexible bonders do as well or better in some cases on traditional substrates like polycarbonate. But more importantly, when you see the graph on the right side of the table, here's where you now start to see some of the flexible substrates coming into play. And on the right side, you actually see the shear strengths for polycarbonate to TPU, a highly flexible substrate that's becoming widely used as a potential PVC alternative. And here you see with the traditional products, the current industry products, you could achieve strengths on the order of about 2.5 newtons per millimeter squared. And with the new flexible bonders, that number jumps to about or over 6 in many cases on a substrate like TPU. So I just want to wrap up the light cure acrylic section. The document that you see on the right-hand side of your screen is what we call a best practice document. And certainly if anybody has an interest in obtaining a copy, just make a note and let us know and we'll share that with you. But just a couple of rules of thumb with regards to handling light cure acrylics. One of the most critical ones is the fact that you have to really be careful about exposing these materials to light, especially during the dispense and assembly process. To prevent premature curing. This is especially important nowadays where a lot of these have visible light photoinitiators in them that do react with ambient light. Stress cracking is also a possibility with many of the adhesive chemistries, and certainly the light cure acrylics are one of them. Towards the end of the discussion today, I'll share with you one of the guides called the Loctite Design Guide for Bonding Plastics. It's a great resource for you to check in and validate whether a plastic is highly susceptible to stress cracking. And in the case of light cure acrylics, these are typically stored at ambient conditions. Recommended is 8 degrees C to 21 degrees C, but I would caution you to ensure you do study your packages and your tech data sheets because there are a few products where refrigeration may be required. And I just want to share a little bit, we're not going to go into too much detail, but also to make you aware that in addition to the light cure acrylics, there are also light curing silicones. So really the key benefit here is really twofold. One is the fact that these are extremely flexible, over 200% elongation, as you might expect from a silicone. And the real place these find a niche opportunity is if you're bonding silicone. Silicone is one of those materials that can be very difficult to bond to. So having a silicone adhesive like bonds to like, these do very well in bonding silicone, and they do offer the light cure capability, so they cure very quickly. On the downside, these are going to act like silicone, so they're going to be a little bit lower in what we call cohesive or bulk strength. And they are resistant to nonpolar solvents, although in the medical area, nonpolar solvents, things like carbohydrates, carbon, hydrogen type materials are not as commonly used, things like fuel. So, but just to be aware that, again, nonpolar solvents can degrade silicones. So let's shift over to the second and probably the second most commonly used technology for adhesives in medical device assembly, and that's cyanoacrylates. You might hear me refer, and others refer to these as CAs. That's sort of the short name of them. They're also instant adhesives, or many people know these as superglues by their common name in the industry. The key thing with superglues, as many of you probably know from home or personal experience, is the fact that they do fixture very quickly. So they develop handling strength very quickly. They are room temperature curing, so obviously no secondary cure means or mechanism is required. And one of the key things that's really beneficial about the CAs, and I'll show you coming up in a next slide, is the fact that they can bond to polyolefins and some other hard to bond substrates. So one of the key things to keep in mind. On the consideration sides, these are thermoplastic materials when they're cured. So what that basically translates to is the fact that from an operating temperature perspective, their maximum temperature is typically about 180 degrees Fahrenheit or 250 degrees Fahrenheit for select grades. So these would not be recommended for high heat applications, repeated autoclaving, etc. And these are resistant to polar solvents, so a bit different than the silicones we just talked about. In the case of polar solvents, probably the most common one people know is acetone. So cured cyanoacrylate can be dissolved over time by acetone or other polar solvents, so just need to be cautious about what kind of chemical exposures might come in contact with a cyanoacrylate bond. And then the last comment on this is because these are what we call surface curing, or they cure from the surface into the bulk of the adhesive, they are somewhat limited in terms of their ability to fill a gap. Where the light cure acrylics can really cure to excessive gaps, the cyanoacrylates really max out at about 10 thousandths gaps. So again, being cautious not to specify these in areas where large gaps are present. So a couple of the common formulation variants available. Surface insensitive cyanoacrylates, these are grades that were specifically designed to cure or fixture quickly whether you have an acidic surface or if you have a really dry environment. They also happen to demonstrate the fastest cure and the highest bond strength on most plastics. So they're really the go-to category when we talk about cyanoacrylates. The low odor, low bloom category, for those that aren't familiar with the concept of blooming, blooming is this white haziness that can form because of excess adhesive, cyanoacrylate adhesive on a bond line. So there are a series of low odor, low bloom grades that do have lower odor, but they also help to prevent the phenomenon known as blooming. And then the thermally resistant are the products that, as I mentioned in the previous slide, that can achieve constant exposure to temperatures of about 250 degrees Fahrenheit. So there are some thermal grades that are available today as well. In terms of some of the newer things that have come out, light curing cyanoacrylates were introduced, about 5+ years ago. And the unique thing about these cyanoacrylates, they are still a cyanoacrylate, so they are still thermoplastics when cured, but they have a light cure component to them as well, so they do allow for being cured by light or by the traditional cyanoacrylate or moisture cure. So where they find use is in applications where you have areas that are exposed to light, but that you might have a shadowed area where light cannot reach. The new flexible cyanoacrylates were introduced last year. There's a product called 4902FL. When you compare the flexible grades to the more traditional CAs, traditional CAs can be very rigid and brittle. You see here that on the Shore D scale, most traditional CAs run about 27 to 80 Shore D. With the flexible CAs, we're on the Shore A scale and around 85. So a higher degree of flexibility, and their elongation perspective is they demonstrate about 30% elongation, which again is a tremendous increase over traditional cyanoacrylates. And then I'll talk about more detail in a few minutes, our new CA epoxy hybrids, and I'll talk about that under the hybrid category. So as mentioned, one of the key areas that cyanoacrylates find frequent use is in the bonding of hard-to-bond materials. So basically, with the use of a cyanoacrylate primer on hard-to-bond materials and a cyanoacrylate adhesive, you can actually achieve, in some cases, strengths that exceed the substrate itself. So on the bottom of the slide that you're looking at now, you see the shear strength values, in this case in PSI, pounds per square inch, of a variety of different materials, starting at the left with acetyl or Delrin and heading all the way over to the right with PU or polyurethane. But you'll see mixed in here several more classically hard-to-bond materials, things like LDPE, PP, which is polypropylene, PTFE, which is commonly known as Teflon. And you'll see the gray bars representing without a primer and using a cyanoacrylate, and then the red bars showing you with a primer. So again, in many cases, strengths are dramatically increased by the use of a primer. So just a couple rules of thumb when it comes to cyanoacrylates. Again, here's another best practice document that you see on the right-hand side. The cyanoacrylates, because moisture does play a part in their curing reaction, it's really important that the environment in which you're operating or using the cyanoacrylates does have some humidity. The recommended humidity for cyanoacrylates is about 40 to 60%, so that's at least the minimum we'd like to see, and typically a little bit higher than that can allow for faster fixtures. Thinner bond lines typically offer faster fixture. These are not recommended for glass or glazed ceramics. Like the light cure acrylics, these can crease plastics. We've talked about the blooming impact with cyanoacrylates and how you might get around that with a low odorable bloom. These are refrigerated for long-term storage, but one of the most commonly misconceptions with cyanoacrylates is that once you take the cyanoacrylate out of the refrigerator and let it reach room temperature and use it, it should never be returned back to the refrigerator. We have many clients or users who do that, and what they find is that it dramatically impacts the stability and the long-term shelf life of the product. So by putting it back in the refrigeration once open, it actually can impart more moisture, which can cause accelerated aging of the product. So we recommend that the products be used within 30 days, and once they're open, that they never go back into a refrigerator after that. So we'll touch briefly on epoxies. I think probably most folks are familiar with epoxies, so you see here some of the key benefits they offer. And again, probably the most important one is the fact that they are chemically and thermally stable. When you look at the considerations, again, in most cases, unless you're talking about heat cure versions of these, there are some lengthy cure cycles, and there's also typically some kind of metering, mixing, as well as a pot life associated with them. When we talk about the formulation versatility for epoxies, you'll see here that on the left side you have one-part versions, so that the Henkel versions of the one-part medical device epoxies, these cure at temperatures as low as 100 degrees C, which in many cases is a relatively low curing temperature because many epoxies do require much higher temperatures than that. And again, the key benefits for these is the fact that they do offer superior temperature and chemical resistance. And the fact that they're one part, there's no metering or mixing required. When you contrast these with the two-part epoxies, these are room temperature curing, but the fixture time and cure times can be a little bit longer. Those can be accelerated by a little bit of a heat bump. There's what we call the 10 degree C rule, which is basically for every 10 degrees C, you increase the temperature, you double the reaction rate. So for example, if you were curing at room temperature, which is, let's say, 25 degrees C, and you bump that to 35 degrees C, you can cut your cure times in half. A wide variety of two-part epoxies are available. And again, they have good temperature and chemical resistance. And there's just a footnote noting here, I'm not going to go over these, but there are two-part polyurethane adhesives available as well. In terms of shelf life handling and rules of thumb, especially with the two-part materials, having the proper mix nozzle and having a smaller diameter mix nozzle really does allow for the best mixing because it does allow for increased shear mixing of the adhesive. So we typically have recommendations for our products, and I would just suggest that folks focus on that and make sure they're using the proper mix tip for that. As I mentioned, we can use heat to accelerate the cure of the epoxy, but one cautionary comment on that is that when you heat something up, you typically cause the viscosity to drop, so you need to have a balance between how much temperature increase you impart versus how flowable the adhesive can become. And then lastly, in many cases with the two-part materials, it's recommended that the mix nozzle, once it's used, be left on the adhesive cartridge because that actually serves as a good tight cap or barrier for until the product is going to be used again. Just touching on hybrids, so this is a new classification of what I'll call structural adhesives, and one of the things that's really neat, unique about the hybrid materials from Henkel and offered through Hisco is the fact that they really do also have universal adhesion. In fact, probably more so even than the epoxies. Like the epoxies and some of the other chemistries, these do offer very good chemical, environmental, and thermal resistance. For anybody that's familiar with MMAs or methyl methacrylates, they have definitely lower odor, substantially lower odor than MMAs. And overall demonstrate improved health and safety. There's none of the corrosive elements that are contained in these products today. On the consideration side, these are two-part materials, so there is going to be some meter mixing and pot life issues. You can vary, the products do vary by toughness, impact, and fixture, depending on what product you choose. And there are some formulas that are not recommended for use on glass, and we'll touch on those in a moment here. So when we look at, there's really two new products that have been made available for medical device use under the hybrid category. The first is Hybrid 4090. It's a CA epoxy hybrid. This is actually a thixotropic or gap filling product. So it's got a viscosity, for those that are familiar with viscosities, of about 5,000 centipoise. And this one's really designed for bonding applications. So having the CA and the epoxy combined, you really do get great bond strengths to a wide range of substrates. This one also has a very fast fixture time. So unlike some of the epoxies, which might have 20, 30, 40, 50-minute fixture times, the 4090 actually fixtures in 3 to 5 minutes. So a very fast fixture time on this one. On the right side, another product, 4092GY, again, another CA epoxy hybrid. In this case, really quite a different product than the one we previously discussed, and the fact that this one is only about 2,000 centipoise, so it's what we call a self-leveling or flowable version. This is gray when it's mixed, so just something to be aware of, that this one does have some color to it. But this does have an elongation of about 70%, so really quite a nice elongation for a structural bonding material. This one has a little bit longer fixture time, so on the range of about 25 minutes. And again, these have also just recently been tested for ISO 10993 for biocompatibility use. And I want to just wrap up the section on epoxies and hybrids, just kind of showing you kind of a comparison when you talk about shear strength or bond strength versus elongation. You kind of get a sense here for the structural bonding categories. The one-part epoxies really are your best in terms of overall shear strength, followed by the two-part epoxies, followed by the hybrids. And then when you get into applications where a high degree of elongation is needed, this is where you would migrate over to the right side of the chart to things like MMAs or silicones as needed. Okay, we'll now go through a few applications for all these different technologies or adhesive chemistries we've talked about, and I'll show you some of the common places that they are used. So when we talk about medical device applications, from a Henkel perspective anyway, we divide it into really 4 quadrants. Disposables, which is really single use, typically a lot of contact with blood, bodily fluids, medication, etc. Non-disposables, which are typically multi-use devices, and they may or may not come in contact with direct body or blood body or blood fluids. And then at the bottom, you really have more of the equipment elements. So equipment tied to disposables and imaging equipment. We're really going to focus on the top 2 categories for today's review of applications. But certainly if anybody has an interest, certainly reach out to Henkel or Hisco, and we can certainly talk with you about the bottom 2. So one of the most common applications for medical device adhesives is needle assembly. You'll see here in the pictures at the top, the circled area shows you where the bond areas typically are in needles or syringe type applications. And this is typically bonding the needle or the cannula into whether it be a syringe, a device, or something else. Below the pictures, you can actually see the various kinds of devices that encompass needles where adhesives would be used. The most common adhesives that are used for needle assemblies are shown on the bottom. So you have light cure acrylics, we have the heat cure epoxies, and the CYANOACRYLATES. So the light cure acrylics, clearly the high speed option. So again, as I mentioned, we have many clients that cure billions and billions of needles in less than a second using the light cure acrylic option. We do have some legacy users of traditional heat cure epoxies. Many have some very extensive heat cure ovens where they have opaque plastics which may not be conducive to light curing acrylics, so they continue to use the heat cure epoxies. And then we do have a few users of either the CYANOACRYLATES or the light curing CYANOACRYLATES for needle assembly. A lot of times you'll see balloons in a variety of different devices. So again, you see 3 different types of balloon devices shown at the top of your screen. Again, here typically the application of adhesive is for bonding the balloon. In the case of the middle picture, in many instances, the adhesives are actually used to smooth out sort of the rough transition or edge between the balloon and the lumen itself. And on the far right side, you see some of the trach applications, which would be similar. In terms of adhesives here, again, like your acrylics, very common, especially where they need precision adjustment, let's say of alignment on that balloon or some of the other components. CYANOACRYLATES, if they're doing difficult to bond material, so if for some reason one of the lumen materials was a hard to bond material, CYANOACRYLATES would be a potential option there. And then silicones are also used here because sometimes some of these balloon-based devices incorporate silicone tubes and balloons. So silicone adhesives, as previously mentioned, would actually afford the best adhesion to the silicone substrates. Tubes, a lot of different types of tubing applications found in medical devices, ranging from IV sets to Y connectors to feeding tubes, etc. You see a few of those at the top. So really, in the case of adhesives, it's really bonding the tube to almost any variety of connector, component, etc. In terms of the chemistries that are commonly used here, again, the light cure acrylics, again, from a transparency and speed perspective, but also if there's a large bond line for some reason that needs to be filled, the light cure acrylics offer that. The CYANOACRYLATES, again, very fast fixture for opaque parts or difficult to bond, and then again, silicones where you see silicone materials being used. On the respiratory side, the applications here sort of run the gamut from a variety of different kinds of masks to bags to breathing circuits and components. In the pictures shown above, these are both mask applications where you're bonding the actual cone to the cushion. Typically, it's a rigid cone to a flexible cushion or pad that actually sits on the patient's face. In the case of the adhesive technologies used here, again, you'll see kind of the same commonality, like your acrylics for high speed, silicones for especially silicone-based, whether it be sleep apnea masks or other masks that incorporate silicone components, and again, CYANOACRYLATES for applications where you have difficult to bond materials. Wide variety of reservoirs and housings, whether they be blood oxygenators, blood filters, heat exchangers, etc. You see 3 different types of reservoirs shown at the top. In many cases, again, these are transparent components, as you can see here, where the doctor, nurse, etc. might need to be able to see the fluid that's inside the reservoir. So a lot of times it's bonding either a component to a reservoir or bonding the lid onto a base with regards to a reservoir. And again, as you can expect here, especially with the transparent parts, the light cure acrylics would be the most commonly used material of choice for adhesive assembly. And again, as we talked about with the light cure acrylics, you have a wide variety of viscosity options. So if you had a situation, which we often do with some of these larger reservoir components where the tolerances are not exactly optimal or tight, the light cure acrylics do allow for the ability to fill some of those gaps and ensure you have a 100% seal. And the CYANOACRYLATES would be used more for the non-transparent applications of adhesive. And then lastly, under the what I'll call the disposable categories, kind of the sort of the catch-all or the miscellaneous other category. So here you have a range of devices from, you'll see at the top there, a flexible endoscope to a suture to a drug testing device on the far side. And again, a lot of times it's bonding and sealing for various miscellaneous types of disposable devices. Same ideas here in terms of the common adhesives, like your acrylics, especially for high-speed production, where you have transparent parts, CAs or CYANOACRYLATES with some of the difficult-to-bond materials. And then the light cure cyanoacrylates, especially in that far right image where you see there may be some potential for a shadowed area. So a cyanoacrylate itself would be fine. A light cure acrylic may present a challenge. The light cure cyanoacrylate kind of combines those two technologies and allows for cure with light, but also in areas that might be shielded from light. And then the last category was, if you think back a few slides to that 4-quadrant, these are really showing a few of the non-disposable applications for adhesives. These tend to be more what I'll call structural materials, so surgical instruments, dental instruments. You'd have some non-disposable endoscopes that are reused, and some medical durables and prosthetics. Again, in most cases here, a lot of these substrates are metals and things that are opaque. And these are also typically devices or materials that might see disinfectant wipes, they might see repeated sterilization, et cetera. So in this particular case, the heat cure epoxies and the hybrids are really the materials of choice, usually for high strength and for that chemical and chemical resistance and temperature resistance. On occasion, if there are some small componentry involved or tight bond lines, you can also see the use of cyanoacrylates. Okay, so we'll go on to the last section, which is really the support and resources of the medical device adhesive program from Henkel, Loctite, and Hisco. So just want to sort of summarize sort of some of the things we talked about. In the case of an offering, the Loctite range of adhesives is more than 70, and it really covers 7 technologies. We really reviewed about only 4 of those today, but if you have familiarity with the Loctite website or our medical selector guide, you can actually view the wider range of those adhesives there. We've talked extensively in the beginning about the biocompatibility program. Henkel also imparts a no-change policy for our adhesives. We do everything we can because we know as medical device designers and manufacturers that you invest money, resources, time, people in submitting and developing your devices. So we do our best to minimize any changes unless absolutely necessary. We do offer global manufacturing, and unfortunately over the last month or so, we've seen a lot of situations where we've had a lot of natural disasters occur. So Henkel is very in tune to the fact that we don't ever want to shut down a medical device manufacturer, so we do offer global manufacturing. We don't easily rationalize our medical device adhesives. We try to keep them alive because we know that they do get specified for devices that could be produced for 5 to 10 years. And then lastly, and hopefully you've seen a little bit of this through some of the technologies I've talked about, we're always looking for new innovations that will help to fit a need within the medical device industry. So just a couple of places that you can go for online support from Henkel directly, and then obviously also Hisco is an option and available to you for support. From a Henkel perspective though, online you can go to our medical adhesives page where you can get everything from the safety data sheets, tech data sheets, ISO certs, and some of the technical guides that I'll show you in a moment. And then also, if you have a specific question that you can't find the solution for online, you can call us, always call us at 1-800-LOCTITE from 8 to 5 Eastern Time. And you can also use that same number if, for whatever reason, you really wanted to have a medical specialist or a local adhesive specialist actually come and see you in person and actually review your application. So in addition to some of those best practice documents that I showed you as we were reviewing the chemistries, here on your screen, you see some of the key support literature that's available to you. Many of these are technical guides. They're not necessarily commercial guides, so they're meant to give you technical guidance or information. The medical device adhesive guidance selector provides a comprehensive list of all the products that are available. So that's the first document you see on the far left. There's also a specific design guide on how to design for assemblies with involving needles. And then there's also a comprehensive technical guide on light curing. So that covers everything from the chemistries of light cure adhesives to curing systems to key factors for success. So all 3 of those guides are available on our website, or you can certainly send us a note as a follow-up to this webinar and ask us for any one of those. On the far right, you see probably some of our more most popular guides. These are our plastic, rubber, and metal guides. These are great resources. They list a variety of different substrates and give you some guidance in terms of how to select the best adhesive for a particular plastic, a particular elastomer, or for a metal. So again, I'd encourage you, if you don't have copies of these documents, to put out a request or go onto the website and actually download those directly.
And here is just a list of Hisco's preferred sources for the Henkel products throughout North America. And you can see here where the Hisco resources are for your particular location. So now we will wrap it up and open the floor to question and answer. As stated before, if you do have any questions, please use the portal to type in your questions and we will answer them.
Okay, so one of the first questions that was submitted was, how can I tell if my light cure adhesive I'm using is fully cured? So it's a great question, and it's one we get quite often, actually, because that's one of the challenges with, especially with the light cure adhesives, ensuring that they've seen that the adhesive has seen light of the proper wavelength and intensity. However, most of our clients, when it comes to verifying adhesive cure, they do typically do destructive testing. There are analytical methods that can be used, but these are typically offline methods. So if anybody had a particular need, they can always work with their Henkel Loctite representative, and we can also help you to determine the degree of cure of your light cure adhesive. So hopefully that answers that question. Another question here is, can the hybrid adhesives mentioned be heat bumped to speed cure? So because these are partly epoxy based, they can be heat cured. Our typical recommendation with the new hybrids is about a 40 degrees C heat cure temperature. That's what we typically have used and seen successfully. So wouldn't necessarily use the 10 degrees C rule that I mentioned for the epoxies, but some low degrees of heat will help to cure the hybrids. Another question here is, the primer that was mentioned for the instant adhesives, can it be used with other adhesives? The primer 7701 that was in the slide where you saw the bar graphs is really designed for cyanoacrylates. So we don't typically recommend, it's really not formulated to add any traditional benefit in terms of adhesion to hard-to-bond materials for other chemistries like epoxies or light cure acrylics. We don't recommend that. In those cases, if for some reason you're locked into that particular chemistry, we would typically recommend, if you have a hard-to-bond material, to use some other surface treatment method like a plasma or corona or something like that. Another question here, are medical device adhesives tested on actual devices for biocompatibility? So in the case of the Henkel medical device adhesives, these are tested in typically one of two ways. And if you recall, one of the key successes with biocompatibility is the fact that they have to be fully cured. But in most cases, and this should be evident in the certificates that you see, is they're typically tested on what we call lapture specimens, or pieces of plastic. They're bonded between the plastic because that's the most commonly used way that the adhesives are used. Or in some cases, we will actually do cured films. But again, in both cases, because there's so many different types of devices and joint designs, et cetera, our goal is really to provide kind of the most generic but best medium for testing. So in that case, it's not on devices. It was really truly on substrates. There's another question here about, are there light cure epoxies and hybrids? That's a great question. There are some light curing epoxies available today. As far as I'm aware, they are not medical device grades yet. And as far as the hybrids, these are brand new technology, so you might be foreshadowing something that might be coming, but today there are no combination cures on the hybrids as yet. So, and then another question here, let's see. How do medical device adhesives perform in liquid sterilants and disinfectants? So that's another good question. So we talked a lot about the fact that gamma, EO, and autoclave, the adhesives do really well. We've also done pretty extensive testing with liquid sterilants, things like glitteraldehyde and some of the other soaking methods. And again, the adhesives do fine. The disinfectants, it really comes down to what the disinfectant is. There are some really aggressive disinfectants that not only attack adhesives, but actually attack plastics. So we've actually been working with plastic suppliers like Eastman, if you guys are familiar with Eastman and their Trident material, which is a disinfectant-resistant grade of material. So it really does depend on the disinfectant in that case, but also on the substrates on which the adhesive has been used, because in many cases those will not withstand that. So I think that was the last submitted question, Liz?
Looks like it.
Okay.
If there's any other questions, we'll give it another couple of seconds for everyone to type them in.
Okay, there's one last question. Does epoxy hold up well to hydrogen peroxide? So There's a couple different versions of hydrogen peroxide. If this is the plasma phase hydrogen peroxide, that is one of the more aggressive sterilization methods that's out there, and we've seen mixed results, again, depending on the substrate and the degree of exposure with that. But if you are specifically asking about the plasma phase, which I think is a J&J method, there are some grades, especially within the heat cure epoxy family, that have the best ability to withstand those. But again, any of the other chemistries, and even the two-part epoxy chemistries, would not likely be good candidates for plasma phase hydrogen peroxide.
Okay, well, I guess we don't have any other questions, so just want to thank everyone again today for joining this webinar presented by HISCO and Henkel Loctite. Thank you. Have a good day.